This is the AP Calculus AB, section 5.5 intro video. I'm going to go over a couple of rules here, do a little bit of practice, then we'll be done. Of course, we'll practice these more in class, so I'd encourage you to think about these rules, take some time to try to remember them, memorize them, and we'll try to use them in class. So here we go. We're going to be looking at the derivatives of some and integrals of exponentials that are not base e. And so the letter A is just going to represent some base. Let's see the letter A all throughout this. It's going to represent some base other than e. All these rules should work for e. Of course, if they don't, we got a little issue. But these rules would work for any other base as well. So the derivative of a to the x is equal to ln of a times a to the x. I think I got cut off there on the video there. ln of a times a to the x is the derivative of a to the x. Or, of course, if the exponent is something a little more complex than just an x, we'd have to use the chain rule. So we would get ln of a times a to the u times u prime. The derivative of log base a of x is next, number 2 there. Let's take a look at that one. The answer here is 1 over x ln of a. And to understand this, there's an old formula that's not used very much because your calculators do this for you, but you can actually change the base from whatever it currently is to whatever you want. So if the base is a, we might want something different. And here's the formula. I would not expect you to do this. I just wanted to show you where this comes from. So if I wanted my base to be e instead of a, the formula is I do ln of the input over ln of the base. So I'll change my base to e. And again, it's not something I'd expect you to know, but that's what it is. It's where this comes from. 1 over ln of a, I'm going to separate that out. So it'd be a derivative of 1 over ln of a times ln of x. So 1 over ln of a would just be a constant multiple because a is a constant. And so we just have to differentiate ln of x and multiply the constant back in. So it's 1 over ln of a times 1 over x, and maybe you can see if you just multiply those fractions together, you get the answer we got before. Okay, and then of course if the input is something more complicated than just an x, we would write 1 over u ln of a times u prime. Of course, because u is a little more complicated than x, the chain rule is going to show up, but essentially it's the same rule, just with that extra factor of the chain rule. And then finally, the integral of a to the x. So these first two rules have been derivatives. This is an integral, of course. So this is just kind of the opposite process of what we saw in number 1. And so the way I think about this is if to differentiate, you have to multiply by ln of a. To integrate, you're going to have to divide by ln of a. You could think of it as a chain rule, like Timmy messed up the chain rule, use substitution. But this is what it ended up being. It'd be 1 over ln of a times a to the x plus c. So you can see it's just the multiplicative inverse of what we saw, at least as far as the factor goes, of what we saw in number 1. Okay, so those are the 3 rules. We're going to use those here with a few examples, and we'll do them again in class when I see you. But please do practice these just to try to get a little more repetition in, and hopefully it'll stick with you. Okay, so number 1, y equals 2 to the x. We're going to just try to follow the formulas and patterns we saw before. We would recognize that the 2 is really in place of the a, and so we would write y prime equals ln of 2 times 2 to the x. Number 2, we see that number 2 is quite similar to number 1, but instead of the exponent just being an x, it's a 3x, and so the chain rule is going to show up here. So we would write y prime equals ln of 2 times 2 to the 3x times 3. That 3 right there, that's the chain rule factor. It had to be there because the exponent was a 3x instead of just an x. If we wanted to compare, technically wouldn't there be a 1 right there on number 1? But of course we probably wouldn't write that because it doesn't really need to be there. All right, number 3, y equals log base 4 of x. Again, we want to look at this as a formula. I think that's the most efficient way to do these. And so we'd say y prime equals 1 over x ln of 4. Okay, let's finish this up. Okay, with number 4, we can see that number 4 is pretty similar to number 3, but instead of the input just being an x, it's a cosine of x. So once again, the chain rule factor will show up. So we'd get y prime equals 1 over U in this case is cosine of x, so 1 over u ln of 10, but then we'd have to multiply by the derivative of that inside, so it'd be times negative sine of x. So of course if we wanted to, we could write this simplified as negative sine x over cosine of x ln of 10. And you could do some trig identities if you wanted to simplify it further, but there's no real need to do that at this point. Okay, finally number 5 is our only integral. So once again, the a is 3 here, right? The constant base is a 3. And so to follow our pattern, we would write that the integral, the antiderivative of 3 to the x dx is 1 over ln of 3 times 3 to the x plus c. And once again, we are just following the formulas here. Like I said, I think I mentioned this a little bit before, I think this is your best idea here. These are relatively simple questions if you know the formula. If you don't, it's going to be really rough. So hope that you'll take the time to get these patterns and formulas practiced and memorized so that when you do see this on a quiz or a test, or maybe even an AP test, which you almost for sure will, then it'll be a quick, easy point instead of something that's going to be a struggle. So I encourage you to do that. When you get to class, we'll practice these some more. Have a great day.